Problem number 12. In acidic buffer, the concentration of salt is 100 times that of the acid. Calculate the pH if Ka is 1.8 into 10 power minus 5. Here the log value of 1.8 is given, that is 0.2553. Options are 5.1, 6.7, 7.3 and 7. So what is a buffer? A buffer mixture is normally contains a weak acid and its salt, or a weak base and its salt. So the buffer mixture or the buffer solution is one that maintains its pH as a constant even after the addition of a small amount of acid or base. So the solution or mixture that maintains its pH as a constant is normally referred to as the buffer. There are two types of buffer mixtures, buffer solutions. One is acidic buffer and the other one is basic buffer. In acidic buffer, a weak acid and its salts, for example, that ethanoic acid, that is acetic acid and sodium acetate. In a basic buffer, what's called a weak base and its salt, ammonium hydroxide and ammonium chloride. And that is an example of basic buffer. So acidic buffer, basic buffer, both maintain their pH as constant if I add a little amount of acid or base. And the pH of these buffer mixtures is calculated by using a very famous equation, that is Henderson equation. By using Henderson equation, we can calculate the pH. So the problem is solved by using Henderson equation. It is like this. So pH is equal to pKa plus log based on logarithm. So active mass of salt, concentration of salt divided by concentration of the acid. So in the problem it is given Ka. So Ka is equal to 1.8 into 10 power minus 5. Therefore pKa must be found out first. You have to take the negative logarithm to the base 10 of 1.8 into 10 power minus 5. So log value 1.8 is given, and if you calculate, you get the value, that is pKa is equal to 4.7447. That is 5.0000 minus 0.2553. So 4.7447 is the pKa value. Now we can substitute here. Now log salt by acid. The concentration of salt is 100 times the concentration of acid. Therefore, here log 100 will come. Log 100 is 10 power 2. So that's the value 2. So pKa value already 4.7447. Now we have pH is equal to 4.7447 plus here the whole thing will give 2. So now we have the value 6.7447. So that can be taken as 6.7, and here the option B is 6.7. So by using Henderson equation we can calculate the pH, and similarly we can calculate the pH of basic buffers also. At that time we have to go for pKb. pKb is the negative logarithm of Kb value. So just like the Ka, from Ka what we have calculated, from the Kb value we can calculate pKb, and substitute in Henderson equation we can calculate. Therefore by using Henderson equation very easily we can calculate the pH of buffers.